Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and today we're going to be talking about the 2013 and 2014 papers, which are on screen but tiny. Don't worry, I'm going to zoom in before I start trying to do them. Hi to people in chat. Hi to Oscar and David. And I also saw Miles is back and some anonymous people are here too. I think I'm joined by Student Ambassador Sishao today to help moderate chat and get things running. Hi Zoe, you're right. We are going to be doing some questions, but first I always like to start by checking how your day was. So we've got a poll going in the chat for how was your day. Bye Zoe. Oh, straight away, 4 and 5 stars. People are having a good day, or at least the people to vote quickly are having a good day. That's always good to see. While you're voting, say hi. I see Pratham Not Gauss is here as well, which is nice. Looking to apply for computer science. Sam's asked a question. Let me read Sam's question. It's like a paragraph, sorry. No offense, Sam. Of course you can ask a question. But, math teacher didn't know. Looking to apply for computer science at Oxford, but joint math computing, other choices. What do I do on the MAT? The rule is that your Oxford instructions beat all other instructions. If Oxford tells you to do something, then that's what you do. If you're applying for computer science at Oxford, this is explained on the front of the test. We've got something called section A of instructions and section B of instructions, and actually this year, because it's a chance to change the chance to tidy things up a little bit, I've made it even clearer that Oxford, we say. Hi in chat as well to Karen and Ben, Will, and no, I know someone with this name. Oh no, I'm so bad at pronouncing names. I'm going to call you Joe. Is the tech demo ready yet? I think it might be. Let's try and find the tech demo. So they've published some stuff. It's on the website we need to go to is www.ox.ac.uk/mat. Now I've never sent people, don't normally send people to this website because I think it's confusing that we've got two, to be honest. But here we go. So I'll just type it in here as well. Let's make it large. There you go. No, wrong, that's my website. There we go, that's where we're going. Can I make that even larger? Yes, I can. Right, cool. That's where we're going. The sort of Central University map page, which looks like this, and has test preparation practice materials. You can watch a video explaining about online tests. There you go, so general advice for preparing for an online test, how to get some past papers. You can watch a MAT specific one, which has got information about preparing for the MAT, which has got information about the maths admissions test. And there is a practice one here. If I click on this, then you can do a sort of start portal thing, which does an impression of what the online portal is going to be like. So questions on the screen, buttons where you can flag questions so that you can remember to come back to them, a button for I have answered this question so you can keep track, but in 2023 people are answering the questions on paper. Next one, just because of my overlay, it's just underneath. There's a next button just off the bottom corner. That's my overlay. I haven't tested the tech demo at the same time as doing a live stream. I guess the moral here is don't run a live stream at the same time as taking the MAT. So there's some sort of examples of what maths might look like. We've typed up last year's questions on here and put some pictures in from there. At the end of the test, you hit a review and submit button. Shows you if you'd flagged something along the way, it would let you know. So you could flag or tell yourself that you've answered questions, and then on reviewing, it keeps track of which ones you've clicked I have answered on or which ones you've flagged, so that you can keep track. And then you get to submit at the end. And that's what the software is going to look like. It's not the most complicated software in the world, but if you want to have a go at messing around with that and practicing flagging, and there's a highlighter tool for selecting things, I think, so you can have a look at that. That is a tech demo of what it's going to be like for MAT 2023, but using 2022 questions. Don't worry, that wasn't 2023 questions in chat. Let's see, people have voted for about 5 stars on the How Was Your Day poll, which is pretty good. Let's turn that back to chat. 4.3 is a pretty good average. Look at that distribution. Always looking out for people who voted for 1 or 2 who are not having a great day. You can obviously go back and amend your answers, because you're answering on paper. So it's a bit odd, perhaps, that the online thing says, I have answered this question, tick, but that's just for you to keep track. In 2023, the questions are on the screen, but you're not actually putting your answers into the computer. You're writing on paper. You've got a paper answer booklet. So you can go and amend just like normal. It's just there's some new online tools in the online portal for you to keep track of your progress as a sort of memo. Like how you might circle a question number in an exam to say, oh, I need to come back to this one. There's a little way that's a little bit like that. Can I turn my volume up? What can I do? If I default it to really quiet again. Can I get a second opinion on microphone volume, please? Am I quieter than normal? I think I'm using the same settings, but I can go and look at it if need be. Second opinion. We're going to go through some of the MAT questions today. Probably not all 7 of them. We've got a voting system for who to pick. I've thought about this. United Nations doesn't say that everyone gets to choose where they study. So unfortunately, we can't all go to Oxford. Okay, 3 people have said volume's fine. Will has got, they say, very loud headphones. So Will, perhaps you could lend your headphones to the person whose volume isn't so good, and that might be good. Okay, hi Keezy. Good. Wait, hang on. I missed a question as well. It was about amending answers. Okay. Recommend for personal statements. Oh, David wants to know about personal statements. It's fine. We know that you write it for multiple universities, and you might write different things. Well, you write one thing, sorry, but we know that you might have different interests. That's allowed. We're not analysing people's personal statements for signs of loyalty or anything weird like that. So, yeah, you can write a personal statement that tries to cover maths and computer science. Cool, right, I think we should probably do some questions. The way I'm going to run this is I'm just going to start doing, I think one of them, this one because it's in the thumbnail. We're going to have a go at this. I think we might have looked at this earlier in the year as well, but we'll have a look at it. And at the same time, I'm going to switch on a poll. Oh, BR says, is it fine to say, yeah, the only thing we actually care about is the answers that you put on the paper. The clicky things on the screen of new and fancy technology, I'm not even sure that data is going to get to me. So it's not a problem if you do or don't tick the thing. The guides they're there to help you out. It's just fine. Definitely, if you've written some maths, there's almost nothing that will get between me and trying to give you marks for it. I'm not going to listen to anyone who says, "Oh, didn't tick the ticky want on the thing." I just want to mark maths that you did. Right. That's my attitude to marking maths versus admin systems. Cool. Yeah, saving time. We're going to do this question that's on the screen. And I said I'd turn on a poll. Should I do that? There we go. You can vote for multiple things. It's which question should we attempt live? And just because it's taking up screen space and it's not doing very much at the moment, I'm going to get rid of it from the screen so that I can have a go at this question. So you don't need to vote for 1E unless you really want to. Okay, so here's a horrible expression involving differentiation and polynomials. We're asked for the degree of the polynomial. And remember, that's the highest power of x that appears. So for example, the expression would be a polynomial of degree 3 because that's the highest power. The coefficients out the front don't matter, I suppose, so long as they're non-zero. You look for the term with the highest power. Now that's complicated in this example that we've got here because, well, our polynomial's got lots of stuff going on, hasn't it? It's got loads of steps happening. But we can talk about the degree of the individual terms, right? So this thing here, for example, is a polynomial of degree 4. And this thing here is a polynomial of degree 5. Okay, so we're going to make arguments like this, which means that when we multiply them out, I really, really don't want to, but I'll get a polynomial of degree 9 for this square bracket. I'm trying to be precise with my bracketing, look, so that I can tell you what's what's going on. We're going to do a couple of derivatives to it, so that'll give me a polynomial of degree 7. Okay. How am I going to write this down? I'm going to draw one big bracket and sort of say everything around here is a polynomial of degree 7. Cool. Catch up with chat. There's more questions about the mat in chat, which I'll come to in a second. I want to finish off this polynomial thing first. Okay. Similarly, we can do stuff over here. Deg 4, and this is also Deg 4. So this thing is degree 7 as well. And then I get a little bit nervous because the thing that I said was you've got to ignore things with 0 coefficients. And there's just a chance that someone out there has been a little bit sneaky and disguised with brackets and things, but disguised the fact that they've given me something like this, right? This is degree 2. This is degree 2, but when you add them, the x squareds cancel out, and you get something of degree less than 2. Why have I thought of that? Well, I guess this option is like alarm bells. It's kind of, if the answer is 7, it feels a little bit too kind of obvious because I haven't done very much work. Both terms are degree 7, so hey, maybe it's degree 7, but maybe there's this kind of cancellation of the x to the 7 term. So what I'm going to try and do is work out that just that top term, the one with the highest power. So why was this degree 4? This was degree 4 because it included a term that was like 2 to the 4 x to the 4. Again, don't multiply that all out, just imagine the top term. And why was that second term degree 5? Well, let's not actually multiply it out because let's just take that term that we're interested in. There's a minus sign here, so minus 1 to the 5 x to the 5. And then we're going to do 2 derivatives on that. Luckily, the derivatives apply term by term, so this is the bit that's degree 9, and there's a degree 8 rest of the terms, but differentiation is doing something separate over there. Okay, when I differentiate this, I'll get, so 2 to the 4 will stay there, that's just some multiple. I've got this minus sign from all of those minus ones. Minus 1 squared is 1, so minus 1 to the 4 is 1, so then there's an extra minus 1. Then when I differentiate the first time, this looks like x to the 9. I can differentiate x to the 9, I get 9x to the 8, but wait, I'm going to differentiate it again, and that x to the 8 is going to turn into 8x to the 7. I did that quite fast, but I just differentiated x to the 9 twice. So first time it spits out a 9, 9 changes down to an 8. Second time it spits out an 8, and the 8 changes down to a 7. Okay, gosh. This term over here, let's do something similar. This has got a 2 to the 4 x to the 4 and a 3 squared x to the 4. So when I differentiate this one, I'll get 2 to the 4, 3 squared, and then this x to the 8 will give me an 8. And right, oh no, these terms really do cancel, don't they? Because they both include a 2 to the 4, they both include 9 is 3, the same thing as 3 squared, and they both include an 8, so this cancels out. So it leaves something of degree less than 7. That's really sneaky, isn't it? It's 2 degree 7 polynomials, but when you add them, the x to the 7 term cancels out. It leaves us with something of lower degree. That's really surprising. Good, okay. Let's have a look at how the voting is going. Did I turn off the voting? Oh no, I kept the voting going, it's still there. What do people want in chat? Quick look at chat joining in. I had to do this question because it's in the thumbnail. People chat voted for questions 2 and 3. Interesting to know. Let's make a quick note before it does this. A bit of a 2, 3, 1H, 5, and then 1F and 1G, and I can see 1J in there as well. Okay, cool. It does feel like a trick question, doesn't it? Let's quickly have a look at comments. I do say gosh a lot, don't I? Andrew wants to know about question 3. The syllabus is not changing. Question 3 is still question 3. And further down, yeah, there's some cancellations. Notgaus warned me in chat down here somewhere, you do need the coefficient, but I agree you need the coefficient, but you don't know when you start. I suppose if you're being very careful, then you would include the coefficient right from the start. I'm a bit more cavalier than that. I want to just, if it turns out these things have completely different degrees, then coefficients don't matter. So unfortunately they do. Maybe that's not a great exam technique. Maybe I should encourage people to be more careful, right? Now wants to know about the 23-13 average scores. I guess this paper was a little bit harder than 12 and 14. I don't know what you think in chat, but further down here, Nav's asking about average scores. And David liked this question, so that's good. What's up here? 1J, and I don't understand the written solution either. 1J is really weird on this one. Trouble finding test centres. It's not too late at time of recording. It's not too late for new test centres to register. Let's get inventive, bit of problem solving. Schools, colleges, local places that could run an exam can still register as a test centre until end of next week, I think. So there's still time to find someone to do the maths. Is it okay? Okay. I don't understand, Jay. Polynomial of degree. Yeah, so the sentence here, like some math questions, we're supposed to be trying to complete the sentence. So it's like degree ... 9, or is the answer 8, or is the answer 7, or is the answer less than 7? I agree. It looks a bit like we're being told the expression is a polynomial of degree, which sounds quite grandiose, right? Like sounds fancy. But Matt does this thing where we're supposed to complete the sentence. Like down here, for example, this information. Maybe we could put ... or something, and you can kind of complete the sentence. I agree that in the E one, that's a bit of a weird way to trail off before you finish. Also in E, they could have semicolons between them, and F, it's full stops between them. Never mind. Yeah, okay. Nav's also said what degree means, but I think it's the phrasing. Maybe that person did want to know what degree means. Cool. Okay. Right. It does feel a tiny bit like a trick question. Let's have a look at 2. I've seen this question before, I think. Cool. I'm going to turn chat off so that I've got more screen space, but I am still looking at chat. A little bit multitasking, right? Remember, in the real test, you don't have to be on a live stream at the same time as doing the test. Instead of writing on the questions, you write on an answer booklet. I didn't say before, but the answer booklet is basically blank paper. It's blank paper that we issue in a booklet with space at the top where we've got a question. We've got different pages for different questions. The answer booklet's quite easy to understand. I think we're putting a version on the website at some point. There exists at the moment a version which is not what the answer booklet is going to look like this year. A sort of really confusing item that's being put on the website at the moment, which is not last year's answer booklet, because last year the test booklet was the answer booklet, and not this year's answer booklet, because things are... Anyway, the answer booklet is mostly blank paper. There's a spot at the top right for you to write your candidate number, so that you can scribble your candidate number on the pages. Your candidate number is a 5-digit number. And the instruction is to use pen in the exam. How many trees do we cut down for Matt each year? That's a good question. It's a lot of paper, really. I suppose if we end up being online, then I'll get back to you. Is there any way we can annotate the question paper? No, so the questions are going to be on a computer screen. So you can't annotate the questions, but you can copy things down onto your answer booklet. We knew that when we wrote the questions. So there's no instructions to annotate a diagram because that wouldn't work with the format. Good. And there's going to be some scanning to get these back. Sorry, I'm still talking to chat, even though I turned chat off. There is some scanning before it gets digitally sent to Oxford. Good. Okay. We've got a function, we've got an identity. Let's do question 2. We're told that a function f of t satisfies this identity, that f of t minus k f of 1 minus t. So it's already a bit weird that we've got f taking the argument t, and over here f taking the argument 1 minus t. And okay, these things balance out to give t for all values of t. And the idea, I suppose, that this is supposed to be true for all values of t. So we could already write down things like f of, I don't know, 1/3, take away k, f of 2/3 is supposed to be equal to 1/3. That's just a fact about f. We've got lots of facts, including the kind of interesting case is that we also know a fact about f of 2/3, right? If I put t equals 2/3, so we've got these kind of joint statements. These are both facts about f of 1/3 and f of 2/3. The relationship there is that 1/3 and 2/3 add up to 1. Good. So we're going to try and specify that switch. Quick answers to chat. Deadline for students to be registered for the test is the end of September. That's on the MAT page. Please get registered by the end of the month. And Andrew wants to know about graphs, which we're going to do in pen. And somebody else says, what if we run out of space? You're not going to run out of space. There's a lot of blank paper, more blank space than ever been given before. It's really rare for people to run out before. Okay, let's actually do this question, I suppose. We're asked to replace t with 1 minus t, and I know that makes people feel a bit uncomfortable because it looks a bit like I'm claiming that t is equal to 1 minus t, and of course it's not here. 1/3 and 2/3 are not equal. But what we can do is write down this kind of statement where I write down f of 1 minus t. This is true for all numbers t, so it's even true for the number, I guess I could use a different letter if that would make people happier, but I think I'm just going to go for it. 1 minus 1 minus t is just t. What I'm trying to do is write down a relationship that, in general, if you've started with 1/3 and you want to switch to this 2/3 fact, because that also includes f of 1/3, I'm trying to generalize that. So on the right hand side here, I get 1/3 and 2/3. In general, I get t and 1 minus t. In general, in the first bracket, I'll get f of the first thing you thought of, and then f of 1 minus that thing when I plug in the other one. F of 1 minus t here will be then the other thing, the other way round. So we get these statements about f of t and f of 1 minus t. Okay, that's all very nice. What's actually happened, I've now got two things like this, and I think I want to do something like add them together. Adding them seems nice because it makes the right hand sides cancel. Yeah, I think I want to add them together. If I add them together, so we're aiming to determine f of t. I suppose I want to eliminate f of 1 minus t. This is like simultaneous equations, right? I've got f of t, which I want, and f of 1 minus t, which I suppose I'll also determine along the way. But if I took these two equations and tried to eliminate f of 2/3, I get some sort of, this is a system of equations. I'm going to make it look more like a system of equations. You ready? Call x equal to f of t and y equal to 1 minus t. And then I've got x minus ky is equal to t, and I've got y minus kx is equal to 1 minus t. So adding them is kind of nice. It gives me a fact about x plus y, but what I really want is just x, and this is simultaneous equations. So I can substitute one of these in for the other. So here I'm going to rearrange this one for y since I want x's. And I'll get something like x minus k. Now what's this y? I guess it's 1 minus t plus kx. And this is going to be equal to t on the right hand side. I've plugged in the second equation into the first equation. So I'm going quite fast. I hope that's okay. I'm going fast because I know that people can pause and rewind. And I know that some people watch at double speed. So I'm trying to be fast for them too. What have I got? I've got 1 minus k squared, lots of x. And I've got some really messy constant. What is it? It's t plus k 1 minus t. Okay, so I suppose that's f of t then. Yeah, I'm going to divide by 1 minus k squared, and I think that's my answer. f of t is equal to, what do I want? T plus k 1 minus t divided by 1 minus k squared. Okay. I think this is maybe the hardest part of the question. I'm not sure, but this kind of messing around with switching the t's with 1 minus t's is, in my experience, the bit that people find the weirdest. Let's see what chat thinks. Sorry, chat, wasn't looking at you for a second there. What does chat say? 2 equations and 2 unknowns. Solve simultaneously. Yes, yes. Oh, brilliant. Chat was playing along as well. Sorry, chat. Multiply it. Right. Good. Yes. Right, so Anonymous says something very honest, which is good. It's one of the reasons I like Anonymous chat. I think you can switch, by the way. I think you can switch between being you and being anonymous. But anyway, so they've said something very honest, which is I think I just fundamentally forgot about how to do simultaneous equations when I did this question, which is fair enough, right? I think it's testing something quite strange, which is your ability to spot that things look like simultaneous equations, even when the objects in them are really weird. Like they're not even these. They're actually these, I suppose, down here. That is really weird. Being able to spot that it's simultaneous equations. Once I've substituted in the x and y, once I've given the things names, now it kind of falls apart, and hopefully you can join in at this point if you can remember how to solve simultaneous equations like that. I think the hard bit is spotting that it's simultaneous equations. Yeah, so some sort of substitutions. Yeah, without the hint, no idea what we would do. Well, I mean, you might eventually think of the hint. And it's not quite a hint, is it? It's more of an instruction by replacing t with 1 minus t. Oh, okay then. Okay, hopefully we're going to try and remember this trick. I can see that later on in the question there's some more t and 1 minus t stuff where we now have this kind of working idea. I suppose the fact that it's exactly the function t hasn't really mattered. Oh, I see. So this had a k in, and this is 1 or something. Right. Let's try. So this is part 1, and then down here, let's talk about part 2a. Then I might need to erase some things to get more space. So this is, if I set g of t equal to t, this is exactly the case with k equals 1. So exactly the case with k equals 1. Everything we were doing before is fine up to a point. So in particular, I can still call x equal to f of t, and I can still call y equal to f of 1 minus t. But now I've got x minus y equals t, and I've got y minus x equals 1 minus t. And there's no solution because if I add those, the x's and y's will cancel, and I'll get 0 equals 1 on the right. The t's cancel on the right as well. So that's not okay. So there's no solution for x, which is f of t. There's no solution for f of t. 0 denominator, yeah. So you can tell that something goes wrong because the solution that I wrote down over here, 1 minus k squared, is just not okay when k is 1. It's one of the things they banned up here, right? Plus and minus 1, so maybe we should worry about that one separately. If I found the answer in terms of f of 1 minus t, I think that's not enough, because I think we're looking for, again, what does determine mean, right? We kind of already have f of t in terms of 1 minus t, right? So if you just write f of t as equal to t plus k f of 1 minus t, then I don't really think that's, you've just moved a term onto the right hand side. You haven't really determined what f is. If you've done something halfway in between, then maybe you could get some of the marks. Is it enough to show no function exists when t is 0.5? It's a good question. Very good question. So we'd have to have, in particular 0.5, any such function would have a value at 0.5, and then f of 0.5 take away f of 0.5 would be equal to g of 0.5. And if g of, well, that's a very good method. I like that a lot. So this will be 0 on the right hand side, but if g of t is t, then this is 0.5. Sad face. Notgauss is calling me out for drawing a sad face to mean contradiction. I reckon a marker would know what that means. Other symbols are available. Some people draw this one, some people do this kind of like lightning bolt thing. I think it's like a devil tail. I normally do this one. I thought I'd use sad faces today. Other stuff going on. Admission tutors do have access to papers. Yeah, they get access to all the questions. The ultimate tutors can see the full scan of it. And we don't get your TMUA grade. So if you're doing TMUA, then we don't get that data. And I'm really sorry if you have to do the MAT and the TMUA if they're on the same day. I'm not sure if they are this year. I haven't been looking at TMUA. Rowan is helpfully doing my job for me and promoting some bar charts that I made one time. So if you want to look at some bar charts that I made one time. And my predecessor in this role also made some bar charts some other times. Look at our bar charts. Thanks, Rowan. Okay, so summary now. We've shown that there's no solutions when g of t is t in this part. And now in the next part, we're asked, okay then, what should g of t do if you want to get solutions for f of t? It looks like we need g of 0.5 to be 0. That looks like we need g of 0.5 to be 0 at least. I think we probably need more than that. So this was someone in chat's clever plan to just look at 0.5. I think we probably need more than that, and we should maybe try and work out how to solve this thing. Let's have a go. So, what have we got? I guess we've got x minus y equals, so reading out this thing in terms of my x and y, I've got x minus y is g of t, and I'm no longer assuming that g of t is equal to the function t. And I've got y minus x. If I do the 1 minus t switch, that is g of 1 minus t. Okay, I can kind of see where this is going, that these things on the left, the x and y things, this one is negative of the other one. So we need g of t to be minus g of 1 minus t. Like, we just definitely need that. If we have that, then I think we're okay. I think we're okay. Help me out, chat. Are we all right? Oh, they're not on the same day. Hooray! And Notgauss wants to know about TMUA. I don't know. I've got a plan, but I don't know. Where does the 0.5 come from? 0.5 was somebody in chat had a kind of clever idea. I've forgotten who it was. Was it Notgauss? 0.5 was a kind of clever idea from someone in chat to just look at one particular value. In particular, it's where t is equal to 1 minus t. So all the arguments over here match up, and then we're just talking about a single value of f. So none of this kind of simultaneous equations stuff. It's a bit like down here, if you'd said, wait a minute, what if x is equal to y? That can happen. X could be equal to y, and then it'd be 0 and 0, and oh no, not 0 on the right. In general, you can just have things. Okay, I've convinced myself that I need g of t to be minus g of 1 minus t, which includes this 0.5 thing, because plugging in 0.5 would give me that g of 0.5 is negative g of 0.5. Only number that's equal to negative itself is 0. Is that enough? I reckon it probably is, so I should now be able to solve this, right? Why can't I see how to solve this? Oh, is it the case that f of t is now going to be something like not a unique solution? Possibly. Yeah, I think it's not a unique solution, which we're going to explore in part C, because we're looking for a solution when g of t is 2t minus 1 all cubed. Okay, so in my head I started trying to solve all of it, solve it in general, but maybe I should stop doing that. this is an example of a function with g of 1 minus t equal to negative g of t. Let's check that. That's, I guess, not obvious at all. So this is, oh my goodness, how does this work? So there's, from when I multiply this by 2, I get 2, and I take off 1, and I get 1. And I also have minus 2t. Oh, and then the cube brings out 3 minus signs. 3 minus signs make a minus. So there's minus g of t. My goodness. Okay, so it obeys the rule that we were just talking about. G of t plus g of 1 minus t balances it out. So now we're looking for f. I'm a little bit worried that now it's kind of underdetermined. It's like a system of equations, right, where we've only got one equation. I'm wondering if I could do something slightly cheeky and claim that maybe f of t is minus f of 1 minus t as well. Maybe that's the case. Sure, I'm not certain it matters. We're just looking for a solution. Oh, okay. So I could try something like half of g or something. Yeah, half of g I think works. Let me show you. So what I'm thinking is maybe f does something similar. So maybe f of t is equal to, maybe minus f of t is f of 1 minus t. So then this minus f of, what if I written it like that? Oh well, then this minus f of 1 minus t will be another f of t. So there's going to be 2f of t. Then 2f of t would be g of t. And f of t would be g of t over 2, which would be 2t minus 1 cubed over 2. And then quickly check that that works. And that does obey f of t is minus f of 1 minus t, because it's just an extra factor of 2 in the g calculation. And in general, I think that is always going to work, that you just do g over 2. Cool, okay, I'm a bit nervous, I'm a bit hesitant, because mathematician sense, right? I don't feel like I found all of the solutions. In fact, I'm pretty sure I haven't found all of the solutions. And up here, I feel like this condition that I found was necessary, but maybe not sufficient. And I'm going to have a quick look at the marks to see how they feel about this. Oh, there are infinitely many solutions. Brilliant. And what did they say up there? Oh, okay, they didn't say anything about the converse. Right, cool. Okay, I'm worrying about nothing. Well, I'm worrying about something, but not something that's worth marks in this particular math question, so I should not worry you with it. What did I miss? Knockout saying, why do you want to solve it? You've answered the question. Yeah, sort of, I guess. Yes. Oh, anonymous person in chat assumed it was a cubic. Went for it. Yes. After all, G's a cubic, so why couldn't F be? And then, yeah, there are multiple cubics that you could pick. You can't quite see. At some point, you and I have to, I think, swallow the pride of not finding all of the solutions and just write down a solution. So just looking for a solution. The thing that makes me really nervous about part B is, of course, what condition must the function satisfy? Well, in some sense, it's this. And in another sense, it's like g of 1 equals g of 1. This is a condition that the function must satisfy. Of course, this is really silly. All functions do this. In particular, g must do this. It's kind of, that's necessary. Like function 101 have a value, but it's not sufficient. And that's kind of like, I'm worrying that this might not be the end of the story, just like this isn't the end of the story. I think I'm worrying about nothing, but it's not quite rigorous. That is not quite rigorous. Right, okay, turned out. So update on the cubic in chat. Something to do with A is 4b plus c is minus 3. And d could be anything, so you've got 2 degrees of freedom there, I think. That makes sense to me? Sure. Oh, and somebody else has got another thing. There's a comma, isn't there, in yours? A is 4, b plus c is minus 3. cool. And D is any real number. Cool, so there's 2 degrees of freedom on your cubic. Right, so some of those have the symmetry f of t is equal to minus f of 1 minus t. I'm trying to think of how you would think of this. I'm not sure I've got a good answer for how you would think of this. Guessing that f looks a bit like g. Any suggestions in chat of how you would do this? I can see people guessing cubics. What's down here? Rewrote 2t minus 1 as t minus 1 minus t. Oh, and then expanded it. Ooh. Somebody else says they put it in Desmos. Fine, okay. Can't do that in the test. Right. Also where I want to go with this, I think. Well, what are you going to plot? You don't really know what f is yet. I guess you plot the right hand side. Try and work out something that works. It's a good cubic, I suppose, because it's got rotational symmetry. Has it got rotational symmetry? Am I making that up? Quick look at Desmos. Desmos. Oh, it looks nothing like I thought it did. I was expecting some nice turning points. Has it got rotational symmetry at the point I said it would? No. Ah, okay. X is 0.5. It's got rotational. Right, good. Thank you, Desmos. How did the mark scheme do this? Aha! The mark scheme from the website, which you can get at that website there, suggests trying a cubic. Yeah. Alternative, more general method is, oh my goodness, something totally different. And then another solution that works equally well is the TG of T. I wouldn't have guessed TG of T in 100 years. And then they say apparently there's lots and lots of solutions. Comes down to, I suppose, these simultaneous equations. If they agree with each other, then you've kind of got a redundant information. You've got a spare variable. I don't love this. Symmetric about the point where x is 1/2. Cool. Okay, so then expand the cubic, you see the symmetry really nice. Oh, okay, that is nice, I suppose. Yeah, I'm going to do that really quickly. Right, if you expand that cubic, then some of the terms are like t cubed, and some of them are like 1 minus t cubed. So when you do the switch, with some minus signs, it's just nicer to see. Yeah, I did think there was something slightly ugly about my multiplication out down here, but no, got to the answer. Who wrote that mark scheme? I don't know who wrote that one. It's from quite a while ago. These days, the web solutions are currently written by me. It's a bit challenging writing the web solutions. Quick aside, I promise I'll talk about more questions. The web solutions have to be absolutely correct. They have to say really correct things, which means that sometimes the things that they say are not quite the thing that you would actually think. The web solution can't really cut a corner, and it can't really just sort of guess a little bit. The web solution has to explain properly. So when I write the web solution, I can't do any hand waving and I can't do any corner cutting. I have to write something that's really quite solid as the kind of example. When I'm talking about the questions on the MAT Livestream, I'm allowed to be a lot more vague and try and give you more of an impression of what it would be like to actually do the question. This is a weird balancing act. Like the absolutely correct versus actually readable is those things shouldn't be in competition. But unless you're really good at writing, it's very hard to be readable and absolutely correct. It's the challenge of this job. Right, cool, enough about my job. Let's do another maths question. I feel like we've done this one recently. So 3 got a lot of votes. Can someone let me in chat? Can somebody let me know in chat? Have we done this question recently or no? Genuinely, yeah? Just get on with it. It's got another K in it. I don't know why there's so many K's in this 2013 paper. Okay, let's spend sort of 10-15 minutes having a look at this. Yeah, I don't think so. Okay, I'm just imagining it. Problem is, I've done this question semi-recently. I'll try and not do it in a ridiculous way. It's tempting sometimes if I've done it before recently. Yeah, last two parts. But somebody else says I think we have done this recently. Herb did this last weekend. Okay. Here's the tricky part. It's understanding this function. So you're probably used to things like f of x equals to whatever. This one's got an extra bit of information. It's got this k downstairs. So maybe we're imagining that there's like an f1 of x, which is x minus 1, x minus 2. That looks quite nice. It's got like roots in all the right places. But also there's like an f2x, which is x minus 2 squared. And this is awkward, but k is just a real number. So there's like an f pi x, which is x minus pi, x minus 2. Except I think they've told us that k is between 0 and 2. Okay, so not the f of pi one. We're not considering that one today, but we are considering the others. And sort of stuff that's in between 0 and 2. This is making me a little bit uncomfortable because it's not quite a sequence. When I write down f1, f2, you're maybe imagining like a sequence, f3, f4, f5. But in fact, it's more of a spectrum of continuous grayscale kind of soupiness between 0 and 2 with all of these functions in between. f of 0.1, f of 0.001, oh my goodness, how many noughts am I putting in? There's kind of f with really tiny numbers, f with things that are close to 2. Yes, this is what the little k means. It's a subscript, and it's supposed to make you think about a sequence perhaps, but in a real way, it just means whatever you have down here, you just put it here. Just like how you're used to taking the x, the input to the function, and putting it everywhere over here. K is technically an index, but it behaves in a very similar way. So here I've tried to show you some examples where I take the number k and that just appears here. So I just replace all the k's. All I'm doing, I suppose, is taking this equation, which is true for all values of x and for k between 0 and 2, and I'm looking at particular examples. I'm plugging in values, so on both sides of the equation. And in general, I think you can get away with this in quite a lot of cases, to put things on both sides. So alternative notation suggested in chat is that they could have written it as like a function with 2 inputs like this, or fkx, or so why not write it like this? It's a good question. I don't really know. These functions with 2 inputs are a bit tricky. If you want to start talking about the derivative of the function, then it can get really messy really fast. And I think this is a sort of differentiation question, so we are going to be doing some integration and stuff with respect to x. It's a way of kind of highlighting one of the variables. Anyway, why is it called a function? What is it called when a function has 2 inputs? It's multivariable function. Is that a real phrase, or have I made that up? More or less. Yeah, I think I'm good enough. A function of several real variables, or a real multivariate function. There you go. That's a phrase. Not Gauss. If you know about partial fractions, if you know about partial derivatives, then I don't know what to say. No, I do. I think you know that partial derivatives are not on the MAT syllabus. Good. Okay. So, what's the structure here? It's another kind of symmetries question. We just had this thing about replacing t with 1 minus t, and there's something similar going on down here. Explain why a of k is a polynomial in k of degree 4 or less. And there's this verify that. Let's try and do the verify that, I suppose. Or maybe not, because I think the verify is just algebra. It's just take the thing we've been given x minus k, x minus 2, and just plug in things. So instead of x, I can see down here there's a 1 plus t, and instead of a k, there's a k. So I'll write out the right hand side, but I'll write k for k, and I will write 1 plus t wherever I see x in the definition up here. And then to understand f subscript 2 minus k, brackets 1 minus t, I'll follow the rule again. The thing inside the brackets, represented up here by x, wherever I see an x on the right hand side, I'll write out 1 minus t. And wherever I see the subscript wherever I see a k in this expression up here, that's the thing in the subscript. So I'll write down, in this case it's 2 minus k. And perhaps it's a little bit weird thinking about k up there, 2 minus k down there. They're different. That's, I think, all that's going on. This one is kind of a placeholder, ready to accept an actual number or function or expression or combination of things. And it's just showing me a placeholder to remember to write that thing, whatever you see, remember to write it here after the minus sign. And then these things turn out to be equal after you've done all of that plugging in. Good, okay. Then there's a question about graph transformations to get from fkx to f2 minus kx. And this is a little bit fiddly. Let's try and draw f of 2 minus k. So that would have roots. So again, I'm going to write out this definition, minus, and then I'm going to put a 2 minus k here. Up here I saw a k, that's the subscript, so I write down whatever the subscript is. 2 minus k, fine. Okay, so this is my cubic. And it's still got a root at 0, and it's still got a root at 2. Maybe you can see that whatever k is doing, this polynomial will always have root at 0 and 2. But now the root is at 2 minus k. This is going to be a picture of f2 minus k of x. And I think it's going to come a bit like this. Not 100% on this picture. Oh, I think it's actually a bit bad. But hey, so the question is, how are these things related together? Maybe you've spotted something about the distances between the roots, or that 2 minus k is not just random. There's a 2 over here and a k over here. The distance between the roots is kind of symmetric. So your first guess is maybe some sort of reflection that's moved the roots around. But of course that wouldn't actually work with the cubic. So reflecting is a good start. It would move the roots from 0k2 to, if you do the reflection correctly, the 0 and 2 roots will swap, and the other root will move from k to 2 minus k. I'm saying if I do the reflection correctly, I think I'm imagining reflecting in the line in the middle, so x equals 1, I guess. That will switch around the roots. But that will take my cubic, and now it will be from a happy cubic to a sad cubic. It will be going down instead of up. So maybe I should also reflect in the x-axis. So maybe I should reflect this way, and then reflect this way. That's a lot. The lumps have been swapped. Yes. This small down lump is the same as this small up lump in the original function, and this large up lump. Same as the down one. Does k dictate a stretch of the function since it changes the root? It turns out no. You can change the roots without stretching the function. For example, if you just take your favourite quadratic and rotate it upside down, then that changes the roots, but there's no kind of stretching that's occurred. It's just now upside down. I suppose maybe you count turning it upside down as a stretch with factor -1, but not stretching. Okay, so there's a sequence of instructions there. Right, do you have to explain it? I'm not sure we do. I think it's never a bad idea to explain what you're doing. But in this case, the sequence is so complicated that probably anybody who wrote it down got some credit, which is reflection in the line x equals 1, and then reflection in the line y equals 0. That actually works. It actually gets you from one cubic to the other. I know that's not very convincing. This description in here is supposed to be a kind of algebraic description of that symmetry, of that combination of reflections. Let me walk you through it. This says that if you start at x equals 1 and you go to the right, you look to the right a little bit, to the right of x equals 1, and you apply f of k, then you'll get something. You've moved to the right by t. Then this says that, for the other function, to get that value, you should move to the left by t, and you should remember to negate it, because what I've done is I've taken my function, it's now the other way around, and it's upside down. So this kind of combination of 1 plus t and 1 minus t means looking on either side of x equals 1, 1 plus t, 1 minus t. And the extra minus sign at the front is a reflection in the x-axis. So it's kind of, the symmetry is kind of hiding in there. The problem is that reflecting the line x equals 1 is quite a hard transformation to spot. You can use part 3 and set x equals 1 minus t. Yes, good. That would be a very good approach. So is reflecting in x equals 1 and then y equals 0 equivalent to, and the thing that that's equivalent to is weirdly a reflection of the thing that that's equivalent to. So reflect in x equals 1, then reflect in y equals 0, or you can just rotate by 180 degrees about 1, 0. That is quite hard to explain, I guess. We've talked, I think, before on the live stream briefly about how 2 reflections make a rotation. You can do this with your hand. If you rotate your hand, if you reflect, which means do it backwards, and then reflect again, that's the same thing as if you just rotated your hand 180 degrees. One more time. Reflect, turning over that way. Reflect, turning over that way. That was hard. That's the same as rotating at 180 degrees. If I sequence that differently, is it easier to actually do? Reflect, reflect, rotate. Still not great. I have since talked to A-level teachers who tell me that reflecting in the line x equals 1 is not on first year A-level maths. I'm not sure if it was at the time, but reflecting in lines that aren't the axes is maybe not on the A-level syllabus, which is unfortunate because this exam does it twice. So I sort of hope it was familiar for students back in 2013 at least. It does it once here, it does it once in one of the short questions. My personal opinion is that, hey, look, people watching the stream, no excuse, you've seen it now, you've seen it happen, this kind of reflection. But it might be unfair for me to expect everyone who's just done A-level maths first year to be able to handle reflections in those lines. Might be a third one actually, or maybe I'm thinking about 2014. More reflection in lines on 2014 too. Got that to look forward to in about 3 minutes. Reflections transformations are fun. The way they compose together to do slightly unexpected things is worth thinking about. You might like to... There's an experiment you can do with a pair of mirrors, right? To test my 2 reflections thing, right? You get an object that's not symmetric so that you can see what's going on. Get a not symmetric object and put 2 mirrors near it at right angles. So that one's doing a reflection up and down and one's doing a reflection left and right. And then look at the image, the mirror image in both mirrors. So you look through one mirror, through into the mirror universe, and then look in that mirror, look in that universe's version of the other mirror. I've made that sound much more complicated than it is. Look across the corner of the 2 mirrors at 90 degrees. I claim that you'll see your object rotated by 180 degrees. Yeah, I think so. Okay. Somebody who is not me is really proud of themselves. Good news. actual James Monroe was proud of you as well. They got an A star. Right, cool. Can I do 1J quickly? Was that the next thing people voted for? I haven't talked about this at the end as well. So the area here, A of K, is the area, and I guess the punchline is that after you've done these reflections, the actual area hasn't changed. So the area for f of k is the same thing as the area for f of 2 minus k. And then by this point in the question, we've decided that A is a polynomial of degree 4. We've decided it's got this symmetry. And then this does just fall out from there, that you could write A of k. It's maybe not obvious that you can always write A of k like this, but you can. Oh, I don't really want these letters of the alphabet. Oh, no, yeah, and I don't want to use capital letters either, because they've got capital letters in the question. You can always write your polynomials like this if you want to. This is kind of like saying you can translate polynomials. You can always write your polynomial out like this. The special fact that A of k is A of 2 minus k means that some of these terms are 0. If you just write out A of k and A of 2 minus k, some of them just cancel. Compare coefficients and some things go away. That was, yeah, a bit weird, a bit of sort of a translation of the polynomial itself. This whole thing is complicated on a kind of question analysis level. Review the question. Because it's just talking about areas, if the first thing you did when you saw this question was to translate everything to the left by 1, then it's all so much easier. Everything's really, really easy, which is a shame. It means that that translation has made everything a lot more complicated, and maybe that's good. J quickly. Yeah, love this sort of thing. So we've got this notation, which I've seen different notation in different places. Chat is over the top. Reflecting in non-axes lines GCSE. Somebody else says no. I'm going to quickly switch off chat. We've got an integral to do. Let's talk about the ideas in this question. We're trying to take, this is called the floor of x. Here we're taking the floor of 2 to the x. So I guess the question is, this thing's always a whole number. So largest integer, oh no, sorry, x is real. It's not always a whole number. When does this change to be different whole numbers? So, okay, 2 to the x. Let's draw 2 to the x first. 2 to the x goes from 1 up to 2 to the n. Is n a whole number? N is a natural number, great. So this is 2 to the x, and it goes all the way up to 2 to the n. And when you come and do the floor of that function, you're taking the largest integer that's greater than or equal to that function at different points. So you'll get these kind of steps where I'm kind of rounding it down. Maybe for quite a while it rounds down to 1, and then at some point it rounds down to 2, at some point it rounds down to 3. And the real question is, where do these things happen? Where does it round? Until finally, I guess it finally reaches the value of 2 to the n, not 2 to the n minus 1, but only right at the point n. So there's this last moment where this last rectangle has got height 2 to the n minus 1. That's kind of the whole question, because we know the heights of these rectangles, they're the natural numbers 1, 2, 3, and this integral is the area. So I want the area under the light blue curve, which is just a whole bunch of rectangles. So add the areas. So if you can work out when these things happen, so this is when is 2 to the x equal to 2, for example. This is when is 2 to the x equal to 3. That's when this jump happens. When instead of rounding down to 2, it starts rounding down to 3. And this one is when is 2 to the x equal to 4. Now some of these questions you can do because you know about powers of 2, and some of them you'll need logarithms. Then there's a bit of a horrible mess of algebra to actually simplify your answer. It's like, we've got to add up these different terms. The algebra is not that exciting to me because the algebra will be different each time. The idea of this like floor function and the idea of integration being the area being in this case made up of rectangles, those ideas feel important to me in terms of your understanding of integration. Actually, can you combine these logarithms together? Fine. I know I love logarithms, but maybe you don't love logarithms as much as me. There's this kind of weird thing that on the multiple choice questions, you can't get marks for your working out. You can't get partial credit. But when you're doing the questions for practice, you can give yourself partial credit. If you got halfway with this, then okay, in the actual exam, fine, technically you would score 0, but actually for your practice and how comfortable you're feeling with the questions, you should give yourself half a pat on the back, right? Full pat on the back for if you've completed the question, but you can award yourself half a pat on the back. Not Gauss in chat is very excited about something called method of differences, which is some way of dealing with all of these logarithms. I think you get a lot of the logarithms have minus signs on them. Well, half of them have minus signs on, and half of them have plus signs, and they kind of almost cancel, which means I think that you end up with slightly more on the negative side, and you end up with, I think, something like this with negative logarithm. There's a bit of simplification there because if you've got lots of separate logarithms, you can smash them together into one combined logarithm using logarithm laws. This factorial here means multiply all the numbers, so this thing is kind of hiding in it lots and lots of logarithms. Cool. I haven't really done any of the bits of that question. Ooh, Anonymous in chat has done horizontal rectangles instead of vertical rectangles. How do I feel about that? That sounds clever. Yeah, that makes the addition easier. You don't have to think about any method of differences, I think, because each of yours are going to have height 1 and then width something sensible like n minus some logarithm, and you know how many of them you've got. Yeah, it's gonna you save yourself some algebra by doing horizontal ones. Prime numbers and prime factorization on the map. Yeah, I think so. To be honest, I think you should just know what prime numbers are. That's why I put prime numbers as one of the map flashcards, so that you can revise for yourself what a prime number is. I can't really remember when people learn about prime factorization, but I think you should forget that. Method differences is a way of messing around with loads of plus and minus signs. It works sometimes. Right, cool. We've reached about 6 o'clock. I haven't done what H. Let's have a quick look at H. Oh yeah, okay, so this is a geometry question in disguise. This thing is secretly a circle, or at least the top half of a circle, and this thing is secretly a straight line. And it's a straight line that goes through the point root 2, 0 over here. So really this is a question about part of a circle. And really what we would like to do is find this angle and this point so that we can talk about the areas involved in this question. Once you've had that idea, then you can, I think, settle on the one which is like a circle take away a triangle. We've done calculations like this before together, I think. Unless, if this is your first time here, hi, my name's James, and to find this sort of area, what you need to do is take a bit of a circle, split it into triangle, for which you know the area is half r squared sine theta, and the whole r, can't remember the word, bit of a circle, for which you know the area is theta pi r squared divided by 360 degrees, or divided by 2 pi if you're using radians. And don't forget to subtract the triangle to find this bit. We'll do the whole thing minus the triangle. Nice to have you on the live stream. Can you guess B? So I did give people some hints before about how B looks the most plausible to me because it looks like a bit of circle minus a bit of triangle. I'm gonna have a quick check, sneaky check. Is it B? It is B. Ha ha ha. So this thing is like Euler lol. This thing is where have I seen that before? That looks like I've seen that number before. Pi over root 8. It's important. Can't remember why. And this thing's just some sort of mad combination of signs. So this kind of looks plausible. It is B. Good. There were some other things people voted for, like F and G, which I'm going to have a very quick look at. So G uses the remainder theorem, which is no longer. Oops, it's gone. There we go. G uses the remainder theorem, which is no longer on the syllabus. So good news. If you haven't been able to do this question, then it's probably because you haven't learned the remainder theorem yet. At some point in your life, you're going to learn the remainder theorem. Challenge to you: when you learn the remainder theorem, come back and have another look at this question. But that'll be in like the future times at some point. Good. Yeah. A levels got changed, so we changed too. F, people wanted F. Yeah. Okay. So this is classic. People. I've been talking about this question to people for years. Maybe I should before we move on to 2014. Is the stream ending? No, so we do a second hour where I talk about 2014 the next year instead. That's a brilliant username. Request for subtitles. And somebody's maths teacher was that. I think YouTube does automatic subtitles. I'm not sure they're very good. Better than they used to be. So the strategy for this is to convert all of these to equations and then try to solve. And if you can solve these to get a unique solution for A at the end, then hey, the answer is A. If you try and solve this, you find, oh, there's two plausible values of A, and I can find corresponding values of B and C, then that's fine, pick B. If you find that actually these equations are really easy to satisfy, I can make A, B, almost anything I like, then you pick C. And if you think I've got no solutions at all, this is nonsense, then pick D. These are trying to be kind of mutually exclusive cases where either is this or that or that or that, depending on how many solutions you've got. Looking at A in particular to just sort of really focus attention. I think this wording caused confusion. I'm not really sure. Certainly when I've shown it to people since, people have been confused by the wording here. Is it the word contradictory? I don't know. Is it a language thing? You can't enable subtitles for this. Not sure why. Oh, I've no idea why that is. I'll have a look in my settings to see if I've disabled it. I haven't meant to. Yeah, cool. Right, how am I going to remember to do that? Subtitles. Enable subtitles? Question mark. What's a good math score to be getting right now for each paper compared to the average on the website? I don't know. If you're getting 50 at the moment, then that'd be pleasing, but it's quite hard to mark your own work. Cool. Very quick break. Remember to look away from the screen if you've been looking at a screen. I've been looking at two screens and a bright light behind there because it's so sunny and bright today that I've got backlight on so that I'm not in shadow, which is just, it's like staring at three lights all at once. Remember to drink water and remain human. Right. I'm worried about subtitles now. Okay, I haven't actually solved these equations. If you want to see somebody solving these equations, why not look at the web solutions down there? But I hope I've tried to clarify there. I hope I've clarified there. I've definitely tried. I hope I've clarified there what we're trying to do. We're trying to solve some equations. Okay, some logarithms around, and okay, we've got to remember these are positive numbers, but we can kind of get rid of logarithms quite quickly. It makes me sad almost that this is a logarithms question, and the very first thing you do is destroy all logarithms and then work with polynomials. Right, okay. I think that's maybe enough. Let's have a quick skim, or we're moving on. Quadratic, that's an easy. Reflections in random lines, there's the other one I mentioned. This derivative one threw people for a loop a little bit. I think it's just confusing. Slightly confusing notation in a way. Sketches, oh brilliant, okay, so maybe try and solve this, rearrange it so that you can make sense of this. Choose one of these graphs. You could use thicker lines for those graphs. That one's no longer on the syllabus. We've talked about the others. I haven't talked about this one. but explore, find out what's going on for small values, find out what's going on for larger values. 1, 1, minus 1, and then some more stuff happens. Why have they told me f of 2? I could have inferred f of... Oh, okay, never mind. It's weird to be given 3 things at the start, right? Normally you're just given 1 or 2, right? Fibonacci numbers have 2, it's got 3. There's some sort of pattern here. Oh, I see it. It only inherits values. Does that mean it's only 1 or minus 1? Probably. Yeah, it's probably only 1 or minus 1. When's it 1? Definitely powers of 2. Is it 1 for any other values? No. Okay, I think I'm done. Right, good. Right, good. Okay. Someone who is not me is having an exciting day. Gosh. 2014? Should we do this one? I'm going to reset the poll. We're going to do some voting. Everyone likes voting, right? While we're voting, I'm going to have a look at the questions. If you haven't seen the questions before, here's your chance. We've got an inequality question. 2014 is the first time the options go up to E. We've got another logarithm question. It's a sketch of a logarithmy sort of thing with a quadratic inside. I like this one because it's actually a logarithm question. There's a reflection of a point in a line. Random line is a point. Where does it go? I think somebody might have just gone in and voted for all questions. Oh no, they voted for all the short questions. Cool. It's tiny point, which is a minimum, so cubic stuff. Over here, largest value of this trigonometric function. Down here, applying these lots of times. What can we say about how many times there were S's and T's? That looks quite tough. Like this one. 1G I've used with people to talk about making choices within choices. I'm quite proud of the explanation I've got for this. Nobody's voting for it, that's okay. And 1H, just tricky to follow through these different cases. Yeah, is this f of 6,000? Okay. Oh, I see, you work backwards. So it's always referring to f of n minus 1, but sometimes you get to add some points. If you see something interesting happen, add some points to your tally. So it kind of naturally adds up some values. Okay, that's got some votes. I and J, obviously. Yeah, so transformations. How do you get from x squared to x squared minus 4x plus 3? It's one of my favourite quadratics. What does that mean for your 2 to the x squared graph? We'll talk about that one in a second. And J is extremely weird. I can do J without determining the function f of x, and I did it like that for quite a while until someone I was working with on a workshop, MAT workshop in Oxford, came up to me and said, I've actually solved for f of x, is that allowed? And yeah, cool. That one's got quite a few votes, 43%. Why has 5 got so many votes? What's going on with 5? So we've got 2, just refined cubic stuff. We've got 3, which is inventing differentiation. That's got some votes. 4 is, so much geometry going on in 4. 5, rhyming schemes. Yeah, okay. Okay, I could do some rhyming schemes. Computer scientists would be happy, right? We did a question 5. We already did this 6. And the automaton question is just fun. It's just good. If you like computer science, you'll definitely like finite automatons. Automata. So here's a way you could learn about what those are. It's a lot of reading, and there's a diagram, but then you actually get to do some finite automata stuff. Good. Okay. Here's what I want to do. I see your votes, and I respect your votes. Q1. Let's do some shorts because I was enjoying that. It looks like you voted for I, J, and G. And then I definitely have to go back and do 5. Okay, thank you for voting. Do the explanation I'm proud of, says Taran, right? Yeah, right. It doesn't really work if no one wants to see it. Is it worth doing papers a second time? Oh my goodness. Probably not. Once you know the answers, it's not really a time test, is it? Because you kind of recognise them. there's probably other things you could do, right? Like other maths questions, or just other things. Are there other things other than maths questions? Find out in 40 minutes at the end of this live stream. No, that's not a real thing. So here we go. We've got an equation here that involves f of x and f of minus x. It also involves the integral from -1 up to 1 of f of x. This is a bit weird. We're just looking for the value of that number, and first surprise. So first surprise. Maybe it's a surprise, maybe not. These things are equal. On the left with x and on the right with t. T is sort of a dummy variable, or just a thing to say, please integrate this function. Put in all of the inputs between -1 and 1, do some addition, do it in the integral sort of way, so that allowing for the tiny changes in variable. But hey, this is just the variable. These things are the same. Call that. I call that A for like the area, right? Both of them represent, if this is F, it's kind of area underneath. I don't know what F is yet, but both of these mean the same thing, the area underneath. So I'm going to call it A for area. And now I've got this expression now that 6 plus f of x is equal to 2f of minus x plus 3x squared a, which is the number. So that's making me think that f of x is some sort of quadratic. Sort of see some f of x, f of minus x stuff going on. There's a quadratic term over here. It's quite tempting to just say maybe f of x is ax squared plus bx plus c, and see if you can make that work. There are several things to check if you want to make that work. One is that the coefficients work when you plug it in here. And two, you want to check that the integral actually works out to be the number a, which is sort of simultaneous equations in a way. Slightly different approach is to take this equation, which is the one in the question, but I've written a instead of writing out that thing, and integrate it. So I really respect, if you want to try the quadratic, plug in a quadratic, solve for the coefficients, then go for it. You've got 4 things to solve for: little a, little b, little c, and big A, the area. But you can do that. There's some relationships going on here. You've got some coefficients to compare, and you've got an integral for the area fact. So you can go for it. But there's this slightly more slick method where you integrate both sides of this equation. It's true for all x, so I can integrate, essentially just taking all the different values of x and adding up the values of these expressions. So the integral from -1 to 1 of 6 plus f of x dx, which is something like this, plus 6, is equal to the integral 2 times f of minus x plus 3x squared a. This one's also with respect to x. Year 10 student, I am writing around your comment. There we go. On the left, I've got an integral that I kind of recognise, because this area, when you add 6, well, you gain. Oh, lost Myro for a second there. Maybe also lost you for a second. Hello again. You gain a kind of rectangle, right? This is like moving the function up by 6 units, so I'll gain an extra 12 units of area, which means that my left-hand side is 12 plus a for that area for integrating f of x. This is why this is a clever idea, I suppose. If you integrate this thing, then f gets integrated and it becomes the a that we were already talking about. On the right-hand side, I've got the integral from -1 to 1. I've got things like f of minus x, but that's okay. F of minus x, because the interval is symmetric, -1 to 1, f of minus x means flip it in the y-axis. Let's see if I can flip this function. There we go. And if I flip it, I'll get the same area underneath if I flip it in the y-axis. So this is 2a plus, and then I've got to actually do some work. I've got to actually integrate x squared. But if I do that, then I've got number plus a is 2 times a plus number. Rearrange it all and solve for a. It's sort of remarkable that this works. that you can solve for this without actually solving for what f is. What do people in chat do? So BR subbed in minus x. Oh yes, also good. Also good, I like that too. Is that even better? So if you sub in a minus x, like we were doing on the 2013 questions, if you sub in a minus x, this is true for all numbers, so in particular it's true for like negative numbers. And 3x squared a, that looks very clever because that's going to balance out, isn't it? And 6 is the same as 6. Okay, so I'm pretty sure that means that if you just take the difference, that f of x is equal to f of minus x. Oh, and now you're basically done, right? Because now this confirms, you move it over and you get 6 minus 3x squared a. You still need to know what a is, so you're going to have to go back and do the integral. Yeah, but it is a quadratic. It's a quadratic that starts with 6 minus. And here's an equation for a. There's an integral to do. Good. What does it mean the equation is symmetric? Did I say that? I'm not sure I know what that means. I'm trying to rewind in my head now. Equations are symmetric. I suppose I might have said something about symmetry over here. There's something nice about the way that x and minus x switch, right? In this method down here that BR suggested. That is clever, I like that a lot. Over here, there's some nice symmetry reflecting in the y-axis. Yeah, the limits are symmetric. That's what I should have said. -1 and 1 are mirror images of each other. You can run into trouble if you're if somebody shows you this bit of the graph and you look at this bit of the graph over here. No, okay, it might be different. What point am I making? The thing is different over in different places, but that's the same place. You flip it over and you get kind of the same picture, but the areas being turned over. I've forgotten what point I'm making. Sorry, year 10 kid. Oh, what's better? 45 AA predicted IB or 4 A stars? Oh, those both fine. Right, yeah. If f of x is equal to f of minus x, that means it's symmetric across the y-axis. Yeah. This has got a name actually. This is called an even function. Even function. Because it's made of things like x squared and x to the 4 and x to the 6. These are examples of even functions. But also other things like cos x are even functions. Cos x is, in some sense, built out of those things, but let's not go into that right now. Even functions. It's good though. Is 3 A stars and an A a good prediction? Yes. Good. Right. Time is ticking. Ooh, okay. I like J. I next. I'm going to turn off chat on the screen. I can still see chat, don't worry. So we've got some transformations to do here, and it's going to come from working out what we do to this graph in order to get to this one. So we're going to start with 2 to the x squared, and then we're going to do stuff. I think it would be helpful to, I want to say complete the square, right? Like to try and make this look a bit more like 2 to the square of something. So I'm going to complete the square to see what happens. So that means to write it like this, where you write it with a square first and then some correction term. The way I think of doing this is I want an x inside the brackets so that I get x squared. I'll put half of this number so that, sneakily, when it gets squared, I'll remember to double it and it'll come back to be the minus 4x. That's 4, and then I'll take off 1 to make so that I get 3. And I think about it in that order, kind of left to right. Okay, that's completing the square. And that's quite nice because then there's some sort of power law stuff I can do to write this as 1/2 of 2 to the x minus 2 squared. Okay, so I think I want to replace 2 to 2 to the x minus 2 squared to 1/2 of 2 to the x minus 2 squared. That's how I would do this with transformations, I think. I'd replace the x with x minus 2, So this is like f of x, this is like f of x minus 2, and this is like 1/2 of x minus 2, which looks like a translation, then a parallel to the x-axis, and then a stretch parallel to the y-axis, which is b. Double check. Yeah, good. Okay. So trick there. Complete the square and try and write it as if you're trying to make this look like f of x. Maybe I should have brought in the f of x notation faster, because all the transformations on the MAT flashcards are in terms of f of x. So if you've trained yourself to spot 1/2 of f of x minus 2, then as soon as you see that, you'll think something like transformations combined. You could take 3 new A-levels. Yeah, you could, I suppose, or you could do other qualifications, or you could get ready. Other ways to get ready. You don't have to do more A-levels. What else did I want to do? A quick look at G, because I've become proud of my explanation. We'll see. The thing to imagine for G, we're looking for a particular coefficient out of this explanation. The thing to imagine is that we've got n of these brackets. You don't actually multiply this thing out, right? If nothing else, there are just way too many brackets. When you multiply this out, in general, you'll get something with an enormous power of x and an enormous power of y. If n is large, then you'll just get like loads of x's and loads of y's. The way you avoid that is if you bring some 1s in there as well. If you know the thing about first, outside, inside, last for multiplying brackets, the more general version of that is when you multiply out 2 brackets, you take every combination of something in the first bracket and something in the second bracket. Every combination. So first, outside, inside, last is a good way if you've got 2 brackets and 2 terms in to make sure you get the pairs of terms between the 2 brackets. In general, if you've got n brackets, then the sort of stuff you get out comes from all the different selections you could make. So if we were going to go work through term by term of multiplying everything out, then at some point we would consider what would happen if we multiplied this thing by this 1, by this y squared, by and then 1, and then this y squared, and like more selections inside here. You would work systematically, I guess, through every possible way to multiply out terms from these brackets. If it was me, I would start with 1, right? I would start with 1 times and then worry about everything else. Then I would start, deep breath, and do xy times and then write down everything else multiplied out. And then y squared times everything else multiplied out. It works systematically. But we're working systematically through every combination of choices of what to pick from the brackets. The reason I'm spelling that out is because that's way more general than this question. This question has got its own sort of gimmick coming up about there being 3 terms and one of them involves x, y. Let's not get distracted by that. This idea about multiplying out brackets is really general. You might like to think about it. Every choice of terms from the brackets, every combination of choices. So every time you pick a term from the brackets, you're building like one thing that you get when you multiply them out. I suppose if I was going to multiply out all of this, I would get 3 to the n things before I simplify for my 3 to the n foil-like terms along the way. Yeah, good. Okay. How do you figure out what you need to do on some of the questions? Didn't think about trying to complete the square. If I don't know what to do, I just start doing random things until I'm getting somewhere. So if I see a quadratic, I might just try completing the square, just for something to do. If you don't write anything, then it's quite hard to have new ideas. But if you start writing stuff, then you might recognize something. It's one of the reasons that I made the flashcards, so that you could practice getting your brain to see something and recognize it and have an idea about what to do next. But if you're like me, it's quite hard to do 2 of those at once, right? So you might need to just write some stuff down, not knowing what you're going to recognize, and then look at what you've written and let your brain go, it's a quadratic, and then you're good. Okay. David's off. Bye, David. Okay. Difference of 2. Difference of 2 cubes. I wouldn't set it as like, what's the difference of 2 cubes? Anyway, let's not get distracted by chat asking about other topics. If it was on a past paper, I think it's probably fair. Okay, here's the bit I like for multiplying things out. The idea that I've got is, if you're aiming for a particular term, you can think about how it's made. So this thing must be made, the x's only appear here, so this thing must be made from xy cubed. That's how you're going to get your x cubed. But then it's not y cubed, it's y to the 5, so there must be a y squared in there as well. So this means that to make a term like this, we choose 1 almost every time, almost every bracket, except 4. Those 4 special brackets, you treat yourself and you pick either xy, 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 y squared in some order. Okay, so we've got a tight budget here. There's loads of brackets, but you can't just help yourself to x's and y's. I'll only need 4 times that you're going to choose anything other than the 1. So you can choose 1 almost every time on your multiplication out. How many ways are there to do that? How many ways to make these choices? Well, there's n choose 4 ways to choose your special brackets. And then 4 choices of how to order these things appear as you're picking them from the brackets. Which one? I pick y squared. So one of those ones is extra special. I will pick not the 1 and not the xi. I will pick the y squared. So that gives me an extra factor of 4. So that's why it's 4 times n choose 4. So that's my kind of method of like choices within choices, and identifying that really almost always you pick 1 when you're doing multiplying out. So within your choices. Yeah, you can also check small values of n, which makes it a little bit obvious, I think. Not obvious, you've got to do some work to check those values of n. If you'd like the MAT flashcards, you can find the MAT flashcards that I sometimes show on the screen in tiny. You can find these on the MAT Livestream website, which is on screen, link in the YouTube description. And if you haven't seen the website before, then that's great. That means that YouTube has recommended this to people. Oh my goodness. Right, Herb's gone too. Good. How long have I got? I've got 25 minutes. What do I want to do? I think I want to do question 5 because everyone voted for it. Democracy. I love democracy. It's about poetry as well. That's nice. What a good wrap up for a Thursday afternoon. Someone very friendly and nice. Look at this. I love chat. Someone nice has given a direct link. So not even like, oh no, yeah. Direct link. Lovely. Good. And there's a picture of the flashcards you can click on. Good. Right. Okay. This is a recurrence question. Recurrence is when you relate your problem to smaller versions of that problem. So if you would like to know the 10th Fibonacci number, well, the rule for Fibonacci numbers is you add together the previous 2. And if you want the 10th Fibonacci number, I can tell you that if I go and work out the 9th Fibonacci number and the 8th Fibonacci number, then I'll add them. How am I going to work out the 9th Fibonacci number? Well, the rule is, the previous 2, so I can go work out the 8th one twice. Let's try and not work it out twice, and the 7th one, and keep going backwards. That's a recursion problem. This is like that, except this one is specified with 2 things that are going on. Okay, so poets use rhyme schemes to talk about the incredible system of rhymes within a poem, which might be like this. First line, second line, and then let's analyze this one, sorry. So like first line, second line, and then the next lines rhyme with those 2. I recognize this, the kind of conventional poetry thing, right? Brilliant, A, B, A, B, yeah, okay. Set it up, set another thing up, ooh, rhyme with the first one, rhyme with the second one, lovely. And then in the second half of this particular poem, C, D, E, D, to break your expectations, where you bring in 2 more new lines, and everyone's thinking, they're going to rhyme with that C thing, but no, a new word that doesn't rhyme with anything appears. Some people don't like that very much when a new word appears that doesn't rhyme with anything. And then D at the end to just wrap everything up again so that that word at the end, that word at the very end of the poem does rhyme. I might look at question 3 if I've got time. Time, never on my side. 6th and 8th lines, right? No, in particular the 7th line doesn't rhyme at all. Right, more precisely, given the letter A, and then subsequent lines use the same letter if it rhymes, otherwise given first unused letter. How many different rhyme schemes are there for poems with n lines? And that's going to be called Rn for how many rhyme schemes for R there are for the number n. There are 5 different sorts of poem you can do with 3 lines. Let's go. There's the AAA poem. This is what they're going to look like, 3 letters, where you write a first line and then everything rhymes. They've got to start with A. The first line is given the letter A. So AAA. I suppose I could do AAB to kind of surprise you at the end. Or AB and then A, back to A again, I suppose. Or I could do A, B, and then rhyme with that one. Or I could do A, B, C, where I bring in a new thing. I'm always allowed to have these kind of things with different, all the lines different. Nothing rhymes. That's poetry. Right, okay. Let's C and K be the number of rhyme schemes with poems line. N lines that use exactly K different letters. Oh, I see. So I just said something about using 3 letters, and this is going to split that down. C3, 2 would mean 3 letters and 2 different letters. So that's describing these 3 sorts of poem. Okay. Oh yes, and there they are. Oh, okay, right, fine. What is C1? That says we've only got 1 sort of letter. So my poem is the sort where everything rhymes. So CN1 is just there's only 1 sort of rhyme scheme there. And CNN, nothing rhymes. I've got N letters, and that's A, B, C, Z, or whatever. So CNN is also 1. Okay. The golden ratio is involved in Fibonacci numbers. I think chat's talking about Fibonacci numbers. I'm trying not to get distracted by the Fibonacci numbers. Okay, so lots of these recursion questions do something a bit like this. So I want to really do this bit. I'm not sure I'm going to do 4 and 5. And just add them, right? And you add them together to get, it's got to have some number of different letters. And then this one doesn't feel that hard. A's and B's, right? So it's not all A, but you've only got 2 letters to play with. So this one feels like you've got to start with A, and you've got to have at least 1 B. So we should rule out the thing that's all A's. But then otherwise, I think you've got free choice of what you do for the other n-1 lines. So I think it's probably this. And I'm not sure I'm going to do this addition and calculation, but let's explain this line and then move on and talk about something else. The thing we're always doing here is to take some sort of logical idea for mutually exclusive cases and trying to use that to count, break down the problem into these different cases. So the final letter of a rhyming scheme might be new, in which case the number of possibilities is just, well, on your previous n-1 lines, you will have used k-1 letters and then throw on your extra letter on the end, which has got to be the next letter of the alphabet because we're using A, B, C, and so on. So for each poem that was n-1 lines and used k-1 letters, we can turn that into a slightly longer poem with a surprise ending that doesn't rhyme with anything. I guess this is a rule of poetry. You can take any poem and throw on the line orange at the end, and that doesn't rhyme with anything in the poem. So you'll get a rhyme scheme that goes whatever Shakespeare was doing, followed by a new thing that doesn't rhyme with anything. Little sort of poetry hack for you there. Okay, or you could, instead of shouting orange at the end of the poem, you could use, so it might rhyme with something already in the poem. In which case it's not an original letter, so if the final poem that we're describing, including my contribution, if the final poem has K letters, has K different sorts of letter, then Shakespeare's poem also had K letters, and I've got a choice. So this is how many poems, it's how many choices Shakespeare had, and then I can either add on I can take one of these poems from Shakespeare and just shout orange at the end, or I can take one of these poems where I'm planning to use the same number of letters as Shakespeare's rhyme poem. I've got a choice. I can decide which line I rhyme with, or to be more precise, I can decide which letter I'm using from the existing rhyme scheme. There are K of those, because Shakespeare in this case has used K letters. I've got a choice. That's the word choice. I've got a choice. I can pick K different things, and I can do that for any one of Shakespeare's poems. I can choose K things for any one of Shakespeare's rhyme schemes. I can come along and just pick from the K different choices of things to rhyme with, pick my favourite word, and down the end, I think I'm going to rhyme with field, yield. Brilliant. Okay. Shakespeare's doing a lot of work here, and I'm really just adding on one line at the bottom. Cool. And this is where I use one of Shakespeare's previous letters. This is where I don't. Okay, cool. And I should add those because those are mutually exclusive. In the orange case, I've got this extra letter, and in the repeating a letter case, I don't. Good. Okay. Why am I shouting orange? I'm shouting orange at the end of the poem to convert a poem with n-1 lines into a poem with n lines. And the point is, you can always do that, and you have this choice to shout orange. That will add an extra line, and orange doesn't rhyme with anything. So it'll give you a rhyme scheme where whatever was going on before, this is a new line that doesn't rhyme. So for every rhyme scheme with n-1 letters, there's a poem with n letters where I just shout orange at the end and nothing, that doesn't rhyme with anything. I don't have to pay any attention to the poem before. I just shout orange at the end and then I get a new poem. Or alternatively, I can pay a bit of attention to the poem, pick one of the words and shout something that rhymes at the bottom as an extra line. That gives me a slightly longer poem, of course, and I get some choice, not quite one choice for each line because that poem might itself contain rhymes. So we should look at how many distinct rhymes there are. Right, round them off. Bye, everyone. Orange rhymes with lozenge. I don't think it does with my accent, but I pronounce things quite weirdly. Cool. Right, I just chatted about orange for like 10 minutes, which is not kind of what I should have done. How should we lay out these kind of explanation questions? It doesn't really matter. I would encourage you to use some words. They don't have to be as stupid as the words that I'm using, but writing down some words is a good idea. So in particular, for this sort of question, you're trying to illustrate that you understand what the cases are and that you understand within that case, just give me something for why it's these subscripts. You and I can both see them in the question, so we're not going to get it wrong, but having something written down, I'd have some words over here to say, and new letter disagrees with all previous letters. So previous poem had, and then I describe the previous n-1 lines a little bit. I think that's just a little bit. Rowan likes it. Oh, there's a name. House is a hill in Wales called Blorange. Is there really? That would be very good. Yeah, it's a prominent hill overlooking the valley of the River Usk. Good fact. There you go. Thank you, Helmut's Fact of the Day. You can have that on the screen. There you go. Learn a thing every day. Right, cool. Okay. I'm not going to do the addition for 4. Use the rule to calculate it in terms of previous problems. I'm sure that's probably fine. And we know loads of values from these two cases as well. It's like edge cases. I'm doing that because they kind of lie on a triangle. Did we do the cat and mouse problem at some point? I can't remember. Okay, I've got about 10 minutes to talk about question 3. Oh yeah, question 3 invents differentiation. Throughout this question, you should use only these properties of f. No marks will be awarded for any use of the exponential function. Okay, so I really like this. It's playing with basic definitions. This is a good use of 12 minutes. Hi, real fun that. Let's join chat. Would I explain why it's only 2 cases? Says BR. Sorry, back to chat quickly. Explain why it's only 2 question cases. It's kind of K+1 cases. I think if you wrote something like the last line is either a new letter or it's not, it's kind of pretty clearly a dichotomy, right? A split between 2 things. If you don't write anything, that's hard to know if you were thinking about it or not. Okay, so what have we got? Derivative of f of x is equal to f, so I'm already thinking of exponentials. It does the exponential thing and it's positive. Okay, great. Ah, no, okay, right, no marks will be awarded. Right, good. Show that f of 0 equals 1. So my plan for this sort of thing is to pick values. We've been told this for all x and y, which is super powerful. I'm going to choose values, probably stupid values. Yeah, probably stupid. Let's try x equals 0, y equals 0. And that'll be rule A. I'm not using any facts about exponential functions. Rule A tells me that, what's that y doing there? F of 0 is equal to f of 0, which has that f of 0 is equal to f of 0 squared, and f of 0 is positive. So this is rule A. This is rule C. Rule C tells me that f of 0 is positive, so f of 0 is 1. That sort of thing, right? I'm just using the rules and combining them together. I get to choose my favourite values of x to stick in here. If I choose 1, what happens there? I get f of 2 is equal to f of 1, f of 1. They've told me to call that a, so that's a squared. Okay, cool. Right, f of 3, it's like f of 2, f of 1, because I could write 2 and 1 for these numbers. Okay, cool. I can kind of see a pattern. Is that part of the question? Maybe, maybe not. Right, okay, we've got an integral to do. Exciting. Which part of the question do people want me to pick out? Quick look at chat. I saw someone in chat. Anonymous wants me to pick out part 4. Inequality construction. Yeah, okay. I'm going to try and get there as quickly as possible. Oh, and I've been told about sporange. Yeah. Do any other admissions tests have flashcards? Not that I know of. We get a request for flashcards, I think. They only exist because someone like you watching this show asked for them, and then we made them. Pretty sure that's what happened. Yeah, I'm pretty sure that's what happened. Good. Let's do this integral. How am I going to do this integral? I mean, I know it's positive, but... Oh, I suppose I could replace this f. This is cheeky, but I could replace the f there with a df by dx. Use this one right to left. Usually when you use a rule, you take the thing on the left. In your problem, when you replace it with the thing on the right, I'm replacing it backwards, which is then just f of x, 1 to 0. F of 1, take away f of 0. Wait, I don't know f of 0. Oh, yes, I do. I just worked out it's 1. That's a. That's 1. Okay. Trapezium rule. Oh my goodness. Trapezium rule is not on the mat anymore. So if you can't do that, then that's fine with me right now. At some point in your life, you'll probably learn about the trapezium rule. Oh, I see. Well, how is this working? So, oh, right, okay. B is f of 1 over n. So f of 2 over n, like I was doing up here, is f of 1 over n, f of 1 over n. So that's b squared, and so on. So there's going to be some sort of geometric series or something going on here. That I kind of know the values of these b things. And in particular, I think b to the n is equal to a. So I can see hiding in here some sort of geometric series. For adding up lots of powers of b. That's roughly how the trapezium rule works. Don't at me, I know the trapezium rule is slightly harder than that, that's why there's extra terms around here. Okay, given that I of n is bigger than or equal to I for all n, so we've been given that. Now this is the part that was requested. I've got 7 minutes. Given that, I'm gonna write it out. I had a good phrase for this. I'm going to read out the phrase again. Part 4 specifically. Inequality construction. The request from chat is to talk about inequality construction. Right, so I'm not allowed to use really very many facts for this one. All I've got really is the previous parts of the questions. And I've been given this fact that in is bigger than I for all n. So I guess I'm hoping that this just rearranges. But there's some strategy here, I suppose. How is this going to go down? So, what can I see? I'm pretty sure that b to the power of n turns out to be a, by the way. B is f of 1 over n, and you can sort of keep adding together 1 over n's. What do I think? So I think this is kind of, I think the thing I've been given with b's in it is kind of code. Yeah, I think it's kind of code for, like, the b's themselves involve some a's. So if I could get a b on its own, yeah, if I could get a b on its own, and then I could replace that b with an a to the 1 over n, and then I could raise over b, I guess hopefully less than or equal to some junk, and then I could raise both sides to the power of n. So I'm trying to work backwards a little bit to see what would this look like just before I get to this line. Imagining one hand on the top of the mountain, right? I'm imagining that I've got to the final line. What's the thing just before? Something like a to the 1 over n. So b on its own. So I guess that's my mission. Try and get b on its own. Okay. Do I know whether a is bigger than 1 or not? No. Do I know whether I is positive? Yes. Okay. So technical note, I is positive because f is positive. Actually positive, because f is positive. We're integrating a positive function. Huh, weird, cool. Okay, so that means that a is bigger than 1. That is me checking that I'm allowed to divide both sides by a minus 1. I've also noticed there's an a minus 1 on both sides. Okay. So, something else that's going on here. I'm trying to move towards having just b's. Something else that's going on is that I've got a fraction there with b on the top and the bottom. And a trick that I learned at some point, or not even a trick, just best practice, is to try and expand that out so that if the degree of the polynomial on the top is equal to or larger than the degree of the polynomial on the bottom, then you can kind of do a bit of polynomial division or just pull out a factor, right? So this thing's about 1 because this thing upstairs is b minus 1 plus 2 over b minus 1. Which looks like a stupid thing to write, but I'm just trying to explain that I'm pulling out a 1 plus from this thing. So really, when I do this maths, I write 1 plus, and then I try and make it make sense. And I imagine multiplying up, and I try and fix it at the last moment. And I think, oh, that would be a b, and then it'd be a minus 1. I don't want minus 1, I want plus 1, so I'm going to add on 2. And now I'm getting to a point where I'm kind of happy because I can see a 2n. I can see a 2 and a 1, and I'm hoping that this all kind of just folds. Oh, there's even a 1 over. I'm working now up the page. This is bad. Nobody. I've run out of space. You won't run out of space. Well, let's go. Put b. Flipping it upside down, inverting means that I should divide it. Flip the inequality, and then add the 1, and then I'm put. Oh, it's gravy. Gosh, to use my catchphrase. So then the last bit, the triumphant step that I imagined would happen, happens. I'll raise both sides to the power of n. Huh. So this says, imagining that the trapezium rule gives you an overestimate for I, which is like, if we told you the fact that exponentials are convex. Is my camera cleaned up? That's because I've got a backlight on. If I turn it off, this is the normal experience. Okay. Finally bought myself the sort of recommended for TikTok video. Why did the flipping the fraction change the inequality? Yeah, and I also got it wrong. Did you spot? I had to fix it over here. I mean, let's do a different one. Let's do like 1 over x is bigger than or equal to 2. Would you like x to be a very large number to achieve this, or would you like x to be a very small number? I think I'd like x to be a small number. I guess. Can I do this in 2 steps? You can kind of do it in 2 steps. Shuffle both things to the bottom, move the other thing up. I'm relying on the fact that x is positive. I guess I should check that b is bigger than 1. Is it b is bigger than 1? Well, a is bigger than 1, and b is the nth root of a, so yes it is. Yep, not Gauss, you're correct. We need to show b bigger than 1. And maybe I was playing games with 2n minus 1 as well. I may have been a bit careless. Divided by stuff. Yeah, so this step here is the step that I just got asked about. I suppose what I'm doing is multiplying up by b minus 1 and dividing by 2n minus 1. And actually both those things are positive, so it's fine. And the b minus 1 ends up on the small side of the inequality. One way to think about that is you turn both sides upside down. But a different way to think about it is that you cross multiply by both denominators and you cross divide by both numerators. And if everything's positive, that's fine. If an even number of the things are negative, that's fine. If an odd number of the things are negative, then you run into trouble. It flips it more. Yeah, b is bigger than 0. Oh right, b is f of much better reason. Yeah, b is bigger than, okay, so b is bigger than 0 because b is f of 1 over n. I actually need b to be bigger than 1. If I'm being careful, so check that this thing works. I bet there's no marks for saying that b is bigger than 1. This kind of caution, if I've learned anything about 2013, 2014. What on earth am I looking at? The web solution goes to no effort to convince me that a or b are bigger than 1. So there we go. Right. Oh, how do we know without assuming? Well, in here, we know that so this is my proof that I is the integral of a positive function, so I is bigger than 0. I is bigger than 0. So a is bigger than 1. And then in here, I decided there was some bit where I skipped some trapezium rule, that b to the n is a, so b is a to the 1 over n, and maybe, trust me, that's also bigger than 1. If a is bigger than 1, then a to the 1 over n is bigger than 1. I've made a mess. Right, cool. It's 7 o'clock. One person wants me to be their lecturer. I'm actually not a lecturer, so that's at the moment not going to happen, but I do some tutorials right now. Gosh, that's really, like, if there a setting on this TikTok light that's less... less day glow. Right, people setting a maths club. How can I get more people in the club? Do stuff that they want to see. And do stuff together. There's lots of cool YouTube videos. You could maybe just watch YouTube videos together, but then also talk about what you saw. So maybe start by looking at a 3 Blue 1 Brown video or something. Like a book club, right? For a book club, people read a book and then they talk about the book. For a maths club, hey, maybe people look at some maths and then talk about the maths. Or lie to everyone. Right, cool. Thank you, Sishao, who's been moderating chat all the way through so that I don't have to click in chat. Thank you for watching. I will see you in 166 hours for another episode of the Oxford MAT Livestream. Have a good evening. Have a good week. Bye. Awkward, awkward, awkward. Awkward, awkward, awkward. Awkward, awkward, awkward. Bye.